The flow of glaciers. Glaciers differ from other bodies of land-borne ice in their ability to flow. This distinguishing behavior has long fascinated scientists and laymen alike, even to the point of a humorous treatment by the redoubtable Mark Twain. Records of surface velocity measurements on valley glaciers go back at least 200 years. Early investigators in the Alps showed that straight lines of markers laid across a glacier were, in due time, deformed into parabolic curves. Much later, repeated photographs of some rapidly flowing glaciers in the Himalayas showed that the entire central parts of these glaciers move with a uniform velocity past marginal zones of nearly stationary ice. In these glaciers, the change from essentially no movement to maximum movement occurs within narrow zones near the margins of the glaciers. This mode of movement has been called plug flow because the central part moves as a plug past essentially stationary borders. Measurements of surface velocity using more closely spaced markers suggest that the flow curve across many valley glaciers is intermediate between the parabolic and plug flow types. As shown by this curve, which for want of a better term we will call a U-shaped curve, the central part of the glacier moves at a nearly uniform velocity, and the transition to slower movement near the valley walls occurs rapidly in narrow marginal zones. Velocity profiles across the Saskatchewan, the Blue, and other glaciers suggest that this sort of transverse velocity curve is probably the most common, although for some reason we tend to overlook this fact. In evaluating the meaning of the shape of a transverse velocity curve, one must remember that the surface velocity is strongly influenced by the thickness of the glacier and the steepness of its slope. Variations in either or both factors affect the shape and symmetry of the velocity curve. Have a great day.